we're going to learn how to make a laser microscope. Does that sound really super cool? It may be a little bit unusual. Well, here's the deal. When most people think of a microscope, they think of something like this. It's got some lenses and it's got a light source and it's got a lot of fancy stuff on it, and it basically uses lenses to magnify something really small and make it something larger so you can see it. Well, water does the same thing. Have you ever noticed when you have a glass of water and you look through it, objects appear larger or distorted? My soda bottle here is filled with water, and you'll notice that when I put my hand behind it, my hand looks really distorted. It actually looks magnified. So water can actually take the place of lenses in very special circumstances. And that's exactly what our laser microscope is all about. Well, instead of using something big and fancy and expensive like this piece of scientific equipment, we are actually only going to be using some pond water that you have, as well as a rubber band and a paper clip and a laser. And that's pretty much it to make our laser microscope. Now, in order to bend your paper clip, you're also going to need a pair of pliers. Let me show you how to do this project. So in order to magnify the image, in order to distort the light so that you can make objects appear larger than they normally are, you're going to need some pond water. Now, you need water that's basically been sitting around and it's been still for a long time. And so that way you're sure that there's stuff living in it. Now, you can make your own pond water simply by taking an old container like a jam jar or something like that and put some warm water in there and throw some dead grass and put the top on and stick it in a windowsill for about a week, and you'll have the equivalent of pond water. You'll have lots of interesting little critters that are going to be in there that you'll be able to see. Okay, so get yourself a sample, and then you're also going to need a rubber band, a paper clip, and a laser. Now, you can use either a red laser or a green laser. You know that you shouldn't shine lasers into anybody's eyes, and that includes animals like cats and dogs as well, because you'll do damage to their eyeball, to their retina actually. And so when you use a laser, if you're using a red laser for this experiment, you want to make sure that you turn the lights down a lot, because the images that you see are actually going to be really hard to see with a red laser, because that actually your eyes are tuned for green, which is why you can see the green beam coming out of a green laser, but not a red. And so your eyes are going to have a little more trouble picking up the images if you use a red laser. Now, if you're using a green laser, I just wanted to let you know that green lasers are meant to be used only outdoors, and they're meant to be used by grown-ups and specifically by astronomers. Now, it may be easy to get a green laser nowadays, but that's what they're intended for. And the reason is this: because astronomers use these to point out to the different stars to their audience when they're out in a big field and they're doing some stargazing. It makes it really easy to point out different stars. Now, the problem is the green laser has a lot more damaging effects than the red laser does. And so what that means is you don't want to ever use a green laser indoors. So if you're going to do this project, take your green laser outside to actually do this project, or make sure you've got your laser goggles on. Okay, if you do this indoors, and that will protect your eyes from the scatter. And so make sure that if you are using a green laser, that it's just the grown-ups that are using it and not the kids. Okay, so how do we do this project? Well, the first thing you need to do is work on your paperclip. So you want to use your pliers and bend your paperclip into this shape, and let me show you how I did that. Okay, so the first thing I did was open up my paperclip, okay, like that. And then I opened this tail end here, and I brought it up like this. And then I took my pliers to make a loop at the end. So now what you want to do is attach the wire to your laser by using the rubber band. Just wrap it around several times, okay? And you see my wires underneath. And then you want to bend the wire so that when you turn the laser on, the beam goes right through the loop that you made. And I'll show you here. So now I have the beam goes right through the loop and onto the table. Okay. Now what you want to do is dip the loop, not the laser, into your water. And so basically the loop is going to hold and kind of stretch out just a little bit that little drop of water that you've got. And all you need to do is turn on your laser and you'll be able to see things. So use a white surface like a white wall or a ceiling, and you want to adjust the distance that your laser is until the little critters swimming around come into focus, and you'll be able to see some amazing things using your laser. So I have two different laser microscopes here, and by simply pressing the button on the red one, I can project an image, and also with the green one. Now remember, if you are using a green laser, make sure it's the grown-up that's handling the green laser, and make sure you do it outside. So what sorts of things can you expect to see? Well, it's going to depend on what's in your sample and where you got your sample from. But you'll be able to see some pretty common things like amoebas and paramecium and so forth. For example, you'll identify a flagellate by the way that it seems to like vibrate itself through the water as it spiral swims through your sample. Now you'll notice paramecium and ciliates like to glide their way through the water. The ciliates are the ones that look like long hot dogs. So here you'll see an image of different critters that are swimming around in our field. Now, do you see how each one of the critters has a little ring around it? Well, you can't really do a whole lot about that. That's just the nature of using water as your magnifying lens instead of using a real microscope. It has to do with the fact that the creature has depth and that the water lens isn't a perfectly shaped lens and so forth. So you're going to see rings around things. They're not really there. It's just an optical illusion. Okay, and so you're going to see all kinds of creatures swimming around depending on where you got your sample from. Now, do you see the two little pointed ears at the center bottom of the screen? Well, that's not a critter, that's a cat that's actually watching this projection onto the wall. So you can still use lasers to entertain your cats, but it's in a slightly different way. So you may be wondering, how does this all work anyway? And how come it works with water? Will it work with other things like milk and orange juice? Well, your liquid needs to be clear, and water works because it's got surface tension. For example, if you tried this with soapy water, well, soap destroys the surface tension on the water. It makes water more stretchy, and so this experiment won't work at all. In fact, you can even try it. And so the water won't stay in the loop at all. So what's happening is inside your loop you have a drop of water, but the drop of water is fatter in the middle of the loop and skinnier on the outside, so it looks like a miniature magnifying lens. That's just the nature of water and what it does. It's because of the surface tension. So it's in the shape of a convex lens. So what you're seeing when you shine light through a lens is you're actually going to see the shadow of the little critters zooming around. That's why it's called a projection. Okay, and that's a little bit different than a microscope because we shine light through it and look on the other side. You can't do that with this particular microscope because if you looked on the other side, you'd actually blind yourself, and that's a really bad idea with lasers. So instead, what we do is we shine it onto a wall and simply watch their shadows. Okay, so that's one way that this is different than a regular microscope. Now, most microscopes have little dials and knobs so you can adjust the magnification. Now, this microscope is much easier. All you need to do is go closer for seeing more detail but less magnification, and further away to see, you can also get some detail, a little bit less, but you can get a much larger magnification that way. And the closer you get, okay, the smaller the objects are, further away, the larger they're going to be. Now you can steady this by putting your laser on a pile of books or on a pile of blocks or something, so you don't get the wiggly effect of trying to hold it simply in your hand like this. Okay, so there you have it, your laser microscope. Go ahead and give that a try.